Today we are going to talk about functional programming design patterns in microservices, and this IPC stands for Inter-Process Communication. So it's a very long title, so I have to use the acronym. I'm working at Wix. Wix is a. Do you know what Wix is all about? Do you have any idea? Amazing, like 3 people in the audience. So what we do actually, we are creating not only a site builder, but we are providing a full toolbox for people who wants to run their small business. So if you're a yoga teacher, for example, then you can build a site with Wix, and you can add schedules, you can upload your video lessons and do stuff like that. So we have a lot of locations, and I'm from Vilnius, Lithuania. So I work in a Scala framework team. That basically means that we are creating a set of libraries, or it's a framework which is used by all other teams at Wix to build their products. And also, although Wix is not a huge company, but it's quite big. And as you can see from these numbers, we have like more than 2,000 instances of microservices running in production. And we have kind of 2 competing frameworks. One is JVM based. It's a Scala framework. And another framework is Node.js based. So we have quite a lot of backend developers. And since we're a web company, we have a huge number of front-end developers. And all of them develop in Node.js, JavaScript, TypeScript, this kind of languages. And since we have Node.js framework, some of these people also can write the backend code. So we have quite a lot of people who are writing, backend code. Also, I am a partnership associate professor at Vilnius University. Associate professor actually means that I am allowed to teach people, which is very brave. And this partnership means that I'm not doing any science. I came from industry, and I'm lucky. I don't have to write any papers. So I started from assisting other subjects, but currently I'm teaching a functional programming course based on Haskell. So I kind of have a dilemma in a sense that my views are very functional and very pure. And I want to see functional programming like everywhere. But the problem is that we as a framework team, we are developing framework for like 300 developers. And the problem is that the level of seniority of these people is very different. We have juniors who just graduated from university, or for example, we have juniors who are ex-lawyers, for example. So, and also we have functional programming gurus and people with PhD. So, it's kind of problem. We cannot just take the functional programming approach and say that, look, people, you are now becoming a functional programming gurus. No, that's not the way it works. So for today's agenda is very simple. We will discuss the way we were writing services. All these services were synchronous and purely imperative. And step by step, we switched to a little bit more advanced approach. Current services are a little more, they are more functional, and they can be asynchronous now. And also, I will share some thoughts about the current situation in the market. And that's it. So, synchronous imperative past. So, we will talk about microservices, how they communicate in the topology of any company. And if you go to Wikipedia, to the source of all my knowledge, then we'll see that microservice is a technique that structures an application as a collection of loosely coupled components. So this definition is really good because it's very short. And the main idea in microservices is that all components must be loosely coupled. That means that you can take away a component from your topology and replace it with another one, possibly written in another language and stuff like that. And the only requirement is that the API should be the same, yeah? But it's not that easy to implement because when microservices communicate, there are always two parts of this history. First of all, we define entities which are used for communication, and all these entities are defined by interface definition language, some interface definition language, like VSDL, like RAML, something like that. And there is also another part of this history. It's a context of the request, like headers, cookies, and stuff like that. And the ugly truth is that usually these things are not defined somehow in a very strict way. They're just kind of documented that you have to have some special cookie in your request for an API to work. So, and these headers might be present, for example, in Kafka messages. I'm not talking about HTTP now strictly. So in Wix, what we do, actually, we are putting a lot of data in the context. For example, user ID or the language of user interface, stuff like that. I mean, we are not passing user ID from host to host. This data is passed through the context. And another example of such context is, for example, A/B testing. Are you aware of A/B testing? What's A/B testing? Okay, well, quite a lot of people. The idea is that we, as a product company, we want to test features in production. I mean, yeah, but you cannot just roll out the feature and see what's going on. What we do, you are releasing the feature step by step. For example, if A stands for the old feature and B stands for the new feature, then, for example, this B feature can be opened for example, for employees for the very beginning. Then you open, you are widening the audience till, for example, 10% of the people and stuff like that. So all this data is passed in the request context. And the good thing about is that actually components do not really care about the content of the context. For example, if we have this component B in the middle, which just acts like a proxy, it really doesn't care about the user ID. It just takes all the context it got from the service A and passes it further to the service C. Is that kind of clear? Okay, so why is it good? Because if we, for example, introduce a new field to the context, then we don't really need any recompilations and redeployments, because all components are kind of dumb. They just take a bucket with key values and pass it further. Yeah. And another thing is that users, I mean the programmers who are using our framework, they don't really need to type any boilerplate, in a sense that they don't need to write a code which extracts, for example, user ID from the initial request and set to the request to the some another service. I mean, users do not write any boilerplate. They just they write the domain logic. I mean, don't really care about users, because users is a domain of a company, not a domain of the particular microservice. So what we did in the past, well, we used Scala as a service definition language. So if you want to expose a service, then you just write a service, a trait, which defines what kind of methods you might have and which entities go in and go out. Yeah. And if you want to call such interface, then what do? You just, well, take some client factory, say, give me a client for this type, service name, provide the URL, and you get a client. And you can then call methods on this client. And the magic happens here. The context propagation is happening. I mean, this client is taking the context of the initial request and passing to actually this host. Yeah. So that's what you're doing if you want to call a service. And if you want to expose a service, then you just implement this trait. For example, you can perform an RPC call, or for example, produce a Kafka message. So we had a very synchronous code. Actually, a lot of developers were quite happy about this because, well, it's easy to understand, easy to debug. There is no magic, well, no asynchronicity, everything is just cool, yeah? But the problem is that Scala isn't the only language you use. We have Node.js, a lot of Node.js, and also we have some Python, some Ruby, and some PHP. And the question is, how do you call this, or better to say, this service? I mean, it's quite easy to call it from Scala because you just take this trait and, well, type down single line of code, yeah? But if you want to call this service from Node.js, then what do? I mean, you just go to this trait, and what you're actually doing, you're doing reverse engineering. I mean, you're trying to write down the correct JSON object to perform, well, this call. So we decided to switch to a more modern technology, and we try to use protocol buffers and gRPC. So are you aware of gRPC protocol buffers and stuff like that? Yeah, cool, quite a lot of people. So, well, protocol buffers are quite simple thing. I mean, you just define, well, your services and entities in a file with proto extension, yeah? And what you do next is you just call some compiler which takes proto files and generates traits and entities in your language. So if you are Scala programmers, then Scala PB is quite an obvious choice because it's pretty much the only product you can take. I mean, if you want to use gRPC. So what you get here is a set of traits and entities, case classes. I mean, Scala PB generated entities are very well, they are decent Scala case classes. I mean, it's not like a wrapper for Java entities. No, with all these options and stuff like that. It's a really nice product. So, and if you want to implement a service, then you have to actually implement this interface, which is generated by Scala PB. Yeah. And it really looks quite the same, but with only exception now you have features. Because gRPC as a protocol is multiplexed and it's fully asynchronous. But, well, what could go wrong? I mean, we released this feature, went to our power users, asked them to try it out, and they come back and say that, look, everything goes well with one exception. If we put an RPC call here, then everything works as expected. The context is propagated correctly. But if we put our RPC client here inside of this feature, then we lose a context. Do you have any ideas what can be wrong here? ThreadLocal, yeah, because our stack relied on the ThreadLocal. And even though ThreadLocal is a very ironic name, because ThreadLocal is actually a global variable, yeah, I mean, yeah, we just use ThreadLocal because our framework is quite old. It's like 7 years old. And 7 years ago, it was quite a decent decision to put everything you have into the ThreadLocal because, okay, I see that some people do not agree. Frankly speaking, I don't agree too, but that's what we have. And we have all the infrastructure which relies on this ThreadLocal, RPC clients, Kafka producers, and stuff like that. And there was, obviously, there was a limitation. You cannot run, for example, 2 RPC calls in parallel because both of them are querying the same ThreadLocal. I mean, you can run, but you cannot run 2 different calls with different data. For example, if you want to impersonate into different people and perform 2 different calls asynchronously, then you cannot do it. I mean, you cannot do it easily. So, so what options we had? Actually, first of all, we just could say that, okay, people, you will have to suffer a little bit and just, well, write the correct code, keep track of all this execution context, well, and you'll be okay. But well, it doesn't work because, well, a lot of people just, they don't really care about all this execution context and thread locals because they just don't know what's that. So, if you ask any functional programming elitist, then probably you will get a reply that you should use a reader monad here because it's an obvious example for reader monad. I mean, you have some context and you are performing calculations in this context. This is really nice and dandy, but we cannot just tell people that, look, guys, now you have to use reader monads. So there must be something in the middle, and I really like where Scala is moving. In Dotty, we might have the thing which was called implicit function types, but I guess we won't have it because we'll have witnesses. Because actually, well, I don't really know what's happening there, but because everything is changing so fast. But the idea is that actually these implicit functional types are some kind of built-in reader monad into the Scala. So what I want to say that we cannot wait for Dotty, we have to solve this problem now. So what we did some kind of reader monad for mortals. So what we actually do, we wrote a Scala PB generator plugin, which generates traits which are a little bit different. The only difference here is that we have this implicit call scope. And the magic is not seen here because this call scope actually is passed to all the infrastructural libraries we have at Wix. So if you see implicit call scope, that actually means that this computation is being performed in some context, yeah. So you can read from it. And if you see that some library like RPC client has this implicit argument as a parameter, that actually means that this client must be executed in some environment. So this is what we did. And well, it was a really nice solution in my opinion, because it's that simple. It reuses Scala syntax. Well, this call scope contains all the data which is needed for processing a request. It's an immutable thing, and you can create a new call scopes by adding some value into the call scope. So this is, well, actually, I believe this is some kind of a new run on the reader monad. So example is, well, which supports all the synchronicity and stuff like that, looks like that. I mean, if you have an RPC client and you want to impersonate into another person, then you just say call scope with value, you change the username, and you can run these clients asynchronously without any problems. So that's how we actually eliminated globals, by replacing globals with implicit arguments. Yeah, so it's all cool, but then we got, well, another request saying that we have to support response context. So basically what's happening here, for example, A is a web-facing component which has to render HTML, yeah? And it calls B. B is just a proxy, it doesn't really care about the quality of the context being passed from and to components C and D. And C and D components are called. And both of them, for some reason, are conducting an experiment. Experiment number 42, which actually says that, for example, if you have the conduction outcome number 1, that means that buy button must be green. And if you have 2, then buy button must be red. For example, we are running such kind of experiment, yeah? And the question is, well, what should we do in the component B? I mean, how should it, well, merge, or what should they do? So obviously, if we have some kind of reader monad for request context, then obviously we should have a writer monad for response context, because we are not reading, we are writing. So if we take some imaginary writer, then we will see a huge problem here. So for example, if we run a writer, here we provide just initial state for the writer, the default state, yeah? And if you run it, then we probably get a tuple, which will contain a response context, the thing which was written inside the reader monad, yeah? And some result of the calculation, of the computation, which we don't really care about. And here we have a huge problem. We have two response contexts. There are two problems. One is very practical. How do I merge them? And another thing is a philosophical question. Why should I merge them? I mean, why should I really care about merging some context? Because, well, I'm not aware of this domain. I shouldn't be aware of this domain. And actually, it's not me who discovered this problem. For example, I've been to this Lambda World Conference a few years ago, and Michael Sneumann actually was talking about this problem, that if you run state monads in parallel, then you somehow have to merge these states, and some libraries, for example, are just discarding one of the states. And that's not what we want to have. I mean, we want to merge them decently. So what he proposed is that instead of writer monad, you have to have a reader monad with transactional variable inside it. So if you have Haskell, then everything is nice and dandy. You just use STM, software transactional memory, and everything is just cool, yeah? But, well, if you're on a JVM, then, well, it's a little bit problematic because we don't have decent STMs. Well, obviously. But for example, in our case, we just use atomic references. So if you have more powerful tools like CATS or ZIO, for example, then you have this ref thing which can be written or updated with a merge function. So, and the good thing is that the merge of the context is happening inside of this reader monad. I, as a caller of this writer monad, I don't really care about all these merges which are happening in the background. So what about merge? What is a merge? So actually, I believe that merge is just a fault over a lazy list. So because what is a merge? I mean, you just take two things and you get one thing. Like you take two fire extinguishers and get a single fire extinguisher, for example. Yeah. So it's enough to have a semigroup to merge to be completed. But actually, a monoid is much more safer operation for that. And well, since we are living in a synchronous world, then this operation, this semigroup operation, must be idempotent. It's well, obviously. And actually, we don't even need a list. We can relax it to a set. So actually, what we do is we are doing something like that. In case of B component, we don't really care about merging. We are just putting all these experiments, all this response context in the list. And this list is passed, well, back. And now, if this A component, which really cares about the domain of this experiment, well, it should render the button in red or green or blue, whatever, yeah? Then it calls this merge function. So this approach is very functional and very lazy in a sense that, yeah, we are not mutating anything. We are just postponing all the decisions as much as we can. And we only perform calculations which when they are really, really, really needed. So, so what we get is, well, is the call scope with such API. So if you want to run a new reader, then you're just calling with value and get a new call scope. And if you want to query this call scope, then you're just calling method value. So if you want to write, you just say put, and it returns unit, because we cannot promise here too much. And if you want to get a value, then we are just calling get. And the funny thing that you have to provide this implicit merge function, which is actually a semigroup over T, but we don't want our users to be frightened. I mean, if we see semigroup or monoid in a type signature, in a signature of a method, then they are stressed. And if they see just merge function, then they are totally okay. So okay, it's performing a merge function. So my message here is that you can use reader monads, writer monads. You can use these algebraic structures, primitive algebraic structures from algebra, yeah, and use them as a correct building blocks for your APIs without even saying that this is the monoid or semigroup. So semigroup is just can be replaced by merge function, or monoid for merge function with default value, for example. So yeah. So this is how we write our services now. And but since we have a lot of different people, and some of these people are really hardcore functional programming fans, then they come and say, look, we want to have Tagless Final. And what we did, well, actually we wrote another Scala PB compiler plugin, which generates a code which looks like that. So the only difference from call scope services here is that, it's not the only difference, there are a lot of differences, is that instead of future, you return some f. And this f has some constraints. It must be, well, it must support some asynchronicity, whatever it means, yeah. And it should contain a call scope, yeah. And for that code to work, we actually have to provide additional libraries. For example, RPC client, which supports these f thingies, or for example, Kafka producer, yeah. And we have a lot of people writing code in this style. Even though I see that a lot of people are struggling with this approach, because, well, everything looks really nice and dandy, but let's be honest, it's quite difficult, especially if you want to debug this code. And sometimes you want to debug this code, or it's not like want, but you have to debug this code. And it's really difficult. And well, the biggest problem of this approach, of this Tagless Final approach, is that, well, the premise behind this Tagless Final is very simple. You write your business logic in a very generic way, using all these Fs, yeah? And after that, you can run your, or interpret your code using different interpreters, yeah? For example, you can run your code in a synchronous way or asynchronous way, or for example, you can even try to print your program, serialize and then deserialize. I haven't ever seen working examples for that, but well, that's what Tagless promises us, at least in Haskell. But the problem is that you see, this Tagless Final approach becomes like a GPA or Hibernate of functional programming. I mean, it promises you that you can change this interpreter, underlying interpreter, but you won't do that. Probably you won't do that. Especially you won't do this in the very middle of your project. I mean, well, it's a huge change, especially if you want to, well, if you have a synchronous interpreter and then you want to switch to a asynchronous interpreter, well, it's really a huge step. You cannot do anything. So I'm not saying that, well, it's a bad idea, but in enterprises, probably you won't do this. And it's still not generic enough. And what do I mean by that? The problem is that actually it's a second. Actually, now we have three kinds of services: the vanilla Scala PB, then our call scope thingy, and now we have this additional Tagless Final thing. Yeah, so we have two additional Scala PB generator plugins, which is, well, we have to support them. And adding this Tagless Final approach, it doesn't solve any problems here. I mean, it's just another way of writing services, but it's not a generic way of writing services. And the problem is, well, actually, the core problem is subtyping, because all these things are based on subtyping. For example, well, we can have this primitive example. We have the service name with two methods, yeah? Everything is nice and dandy here, but what if we want to add tracing to our methods? Then we just go and add tracing, yeah? Okay, then after that, we want to add some generic authorization of your service. Then what do? You go and add authorization, and you do it as many times, even though this authorize is pretty much the same as this authorize, and this trace is pretty much the same as this trace. For some reason, you have to go and write the same boilerplate. Because, well, the reason is very simple. I mean, you don't have a function, you have a method, which is, it's very difficult to compose methods. And why don't we use functions instead of methods? Well, in our case, we started to generate traits by some inertia because Scala PB is generating traits. Why Scala PB generates traits? Well, probably because Java gRPC generates interfaces. I mean, but it's a completely wrong building block for functional programming. So we now are thinking about a little bit different approach of writing services. And for example, we might have a little bit more complicated example, like a calculator, which supports a little bit more operations. Or we can use, for example, streaming, which is built into gRPC. For example, in this case, we can request a stream. We just send a single value and we get a stream of single values as a response. Or we can send a stream, we can stream single values and get a single response. Or we can have this bidirectional streaming, yeah? And I believe that, well, all we have to do is just generate a request and respond some algebraic data types for these methods and responses. And your service must be a function from request to response. Now we have these U and S, which are types for unary asynchronous type and streamed asynchronous type. So if we have a monix, for example, then we'll have task and observable, and then we are just doing this pattern matching, message dispatching actually. And this add, for example, stands for add methods. Add method, which contains request value. And for streaming, it's getting a little bit more complicated because in some cases, this S is not a single value, it's a stream of values. So in some cases, it's a unary value, or in some cases, a stream of values. But, well, using monix observables, it's quite easy to deal with these streams. You just folding, you can call asynchronous, I don't know, databases here, or do whatever you want. And if you don't want to use monix, then, for example, you can switch to Zio, the new fancy functional programming library, and your code really looks the same because all this calculator function remains the same. It's really generic. It works with monix, it works with Zio, and it even works with vanilla Scala functions. Actually, In this case, we do not support any streaming because there is no primitive library out of the box in Scala for streaming. Well, for some reason. So this is the idea we are playing with. I mean, it's not that we are using it at the moment, but probably we will. And actually, you can, well, just go to this repository and see. Well, give it a try if you really want to write gRPC services, if you're writing gRPC services. Yeah, so that's pretty much it. So the main takeaways of this talk. First of all, well, it's obvious. I mean, just use algebraic structures. I mean, they're really nice. They are correct building blocks for building asynchronous distributed systems. And but the message here is that you don't really need to name them. I mean, just use merge function instead of semigroup. I mean, if you are not allowed to introduce some functional stuff into your code, or you are allowed, but you cannot do it because, well, you can affect like 300 people, then just name them somehow in another way. And, well, that's pretty much, well, it works. Methods and, well, actually traits or subtyping or inheritance is a very bad building block for APIs. If you can, just strive using functions, because functions are really cool. They are composable out of the box. And if you are asked what is a monad, well, this is a very decent answer. It's a design pattern. And it works with pretty much any audience. I mean, if people from functional programming, they know what is monad, sorry. And if people are from object-oriented programming, then you just say, hey, it's a design pattern. And people buy this argument because probably they just don't want to confess they don't know this design pattern, because you have to know all of them. But the message here is very simple. I mean, you don't really need to name your, well, classes with reader, monad, state, and stuff like that. I mean, there are a lot of jokes about Java programming having all these prefixes like visitor, factory, facade, and stuff like that. Why it's so funny? Because you are naming your classes after design pattern which is used. So pretty much the same situation we have in functional programming. We might have a reader without naming this thing a reader. And this is what we have, for example, in Zio library. I mean, you won't find a monad there, even though it has all these maps, flat maps, and the look and feel of this library is fully monadic. Or for example, we have Elm, we have, I don't know, Rust, for example. They have all these flat maps, but they don't have this common monad in their class or interface hierarchy. So pretty much it. There are some references. I will, well, publish this PDF of this presentation, well, in my Twitter. Here it is. So thank you for listening, and maybe you have some questions.
Yeah. If anyone has any questions, I'll be happy to bring you the mic so you can be heard. Oh, cool. Sorry, can you raise your hand?
Hi. I wanted to ask, how long did it take you to make a transition from the first style of programming to the more functional one?
More for functional. I mean, okay, we are a product company. That practically means that we'll have legacy code for like forever. Yeah. So it's not like we will rewrite all these 400 microservices. Yeah. So, but introduction of these closed-scoped services took like. Okay, we got our first users like after half a year, yeah, and now we have like a year and a half from the very beginning, because we started this project like last summer, something like that. And currently, look, there are a lot of people who just want to use this synchronous way of programming because, well, it's very comfortable, yeah. But if you come to some, well, if you come to some teams, some products, and say that, look, you can call other services asynchronously, for example, without any headache, yeah, then it really buys a lot of users. And currently we have like, I don't know, like 20 or 30 services written in this new style. And it took like a year and a half. Yeah, it's a very slow process. I mean, I would be happy if everyone just adopted this new way, but, well, it doesn't happen for some reason.
Okay, perfect. Any more questions?
Here, I guess.
You said you have microservices in Node.js. How are you supporting that style of context passing on Node.js or other languages?
Yeah, so what we have to maintain this feature parity. I mean, if we have this, for example, context back propagation of or propagation of response context, then what we do, actually, we implement it in Scala first, give it a try. And after that, we have a dedicated Node.js team who are maintaining a framework for Node.js. And then they just re-implement it one more time in Node.js. There is no magic. So that's why probably we don't have a lot of languages supported, because you have to maintain this feature parity, because you want to have, well, once again, you want to, well, take away the component, put another component in the same place, and you expect it working. So if you, for example, want to implement a new service in Kotlin, then you will have to implement all this response context propagation from the scratch. And that's what you won't do in a product team, because you have a product. So yeah, so there must be a dedicated framework team who actually supports this feature parity.
Just out of curiosity about technicalities of this context passing, how is it propagated? What is the transport medium of this? Is it like an implicit IDL extension, or how do you propagate this context?
So look, so it really depends on protocol you use. Yeah. So in case of old RPC, which is a JSON RPC, so it goes over HTTP1. So what we do, we just take all these key values and render them as headers with some special prefix. Yeah. For gRPC, we have a header which contains a map. It's a binary map. So we use a single header. And for response context, it's not a header, but the trailer of gRPC, which is really nice. I mean, because, well, gRPC is cool because it uses HTTP2, which actually means that you can start writing a response, and if something happens bad or good, then you write a trailer informing that this is, for example, not a complete response. Yeah. So you don't have to calculate, for example, response context in the very beginning and then render the content. It's an opposite way. So, and for example, for Kafka, we use Kafka message headers. So it really depends on protocol.
Okay, I think we're finishing just on time, so I guess there will be some time during the break to approach the speaker.
So just, well, approach me and ask any question you have.
And thank you for the great talk.
Thank you.